Hello everybody, welcome to my channel. Today I'm going to show you how to connect the microphone and speaker into the development board. So in last video I showed the I2S example on how to use how to run the nRF examples in the development board, and this time we are going to use the I2S to connect both microphone and the speaker. So you can see here I have already connected the speaker and microphone here. So they are basically connected to the same I2S interface. You can see here this is the microphone, and I just get it from the web, the AliExpress, and this is the nRF52832 microphone. This is very common, so you can actually see here. If we go to the AliExpress, so many items. Okay, nRF52832. So you see this. There is a lot of different products that you can buy, and it's basically the same, and it's like a couple of dollars, and some even have the shipping included, which is very good. And this is a I2S microphone, so that means we can connect directly into the board. Also then this is for the microphone, but one problem of this microphone is that it's already stopped producing. So if we want to make a audio system, we probably need to consider to use the one that is still in production. Therefore, yeah, we don't have problem of the parts shortage later. Then for the speaker, I have actually the speaker is the normal speaker from Knowles, and this is an analog speaker, which is also about €1, a little bit more than €1. And then in order to be able to connect this speaker, we need to also have an amplifier in order to accept let's say the signal from the I2S interface, the output, and then being amplified and then to the this speaker. So the one I'm using here is the one, it's also quite popular. It's from Maxim company, so it's called Maxim 98357. Yeah, here you can see it's also like $2, $3 range. If we click just one of them, yeah, you got the left-right clock, you got the data in, and there is also some setting of gain. If we don't connect those gains, then by default you got 9 dB here. So yeah, this is the clock, and then this is the disable pin. So we usually if you put it to low, then this chip will be disabled. So, and then the general ground and the input power. So this is also very straightforward, so we can just connect directly those pins into our development board. In my case, I have this, as I said before, in the middle there is a from general I/O pins from 2 to 7, so we can just connect from for those ones. So actually I have the clock. I have a clock. I have the left-right, which is the word select as well. I have those pin to 2 and 3. You can see I have also soldered them together. So basically the speaker and microphone, they sharing the same clock and also the word selection signal. And then we have two input. One is the microphone signal input into the pin 4, and then the output is 5. Actually put it output to the this maximum chip. So then it can drive the speaker. So as this setup, currently we just use the wire, but for this setup actually it's quite straightforward. So that if we go to the application, it's basically similar to the I2S example I had before, but I think you can see the configuration. Also the pin, as I said, the clock is pin 2 is in here. Pin 2, it's in here, and then the pin 3 is basically for the word selection, left right clock, let's say. And then we have the SD out is to the speaker, and then the microphone here. The microphone input is basically to pin 4 right here. So with those configured, we should be able to let's say get the signal, microphone signal input, and also we can output the signal into the speaker here. Okay, so one thing to be noted is also that we have this I2S signal, which is the sampling rate that we are setting to 16K, just as the example has. And here we can see there are actually provided the division. So if we want to calculate it, so it's 32 megabytes, let's say. So let's 33. Okay, so this is 32 megabytes, and then it's actually have a division of 21. So let's say divide by 21. And then there is another division which is divided by 96. So we got a 15873 as the frequency, and this is 15K, around 16K hertz. So sampling rates. So that means we have the bandwidth around 8 kilohertz for the normal speech conversation. For the 8 kilohertz is actually good enough that we can understand. But if we want to have like really from 20 to 20K, then we need to at least have 40K sampling rates. So with that being said, then it's basically the same as I2 example, but what we are doing here, actually we do the same. We get the audio samples, and then we have also in the meantime the send out. So basically we just grab the input of the microphone, and then we put it directly into the output buffer. Therefore, what we really have is the looping through. So the microphone pick up the signal and then directly send it back to the speaker. So in this case, we didn't apply any gain also. So yeah, then we shouldn't see any like being louder or something. But if we want, we can also create a feedback. Then we know that the input is actually put into the output. I can show you later on. Then also here I have some preparation for the FFT, because I want to do the FFT analyze. So there is also helper function that I put in using the ARM FFT, and then calculate from the complex output to the magnitude of the different frequencies. But this one is not yet used. So okay, so with that we can actually rebuild. A little bit bigger. then we should be able to see it's been built, and you can see the output here. And what we're gonna do is we can actually start a new window here, and then we go to the SDK folder, and then let's okay, so yeah, okay, we can do it from here. What we need to do now is we need to convert our generated binary. That's I2S, and then we here I2S hex into the I2S zip. So with that we actually created the DFU package, and then after that we just use our old trick to actually burn that into the device. Then I2S, and let's do the reset first, and then right after the reset we press the enter. Then you should be able to burn the firmware into the device through the bootloader. So let's do that. Yeah, you can see this time it's a little bit bigger. Okay, so now it's burned, and then we can see the light, but we don't use that light. How do we gonna know if the device is working? So we can first do the PuTTY here. As usual, we load the TTY USB 0, which is the UART interface here, and then we say open. Nothing come out. That's because during the processing we didn't use any serial output that will slow the speed. So let's do the reset, and then we can see the I2S loop at example started, and then audio capture also initialized, and I2S initialized as well. So this is a good indication. But then another easy way is to, let's say, just create a feedback, and I mean ideally, because we take the signal into microphone and then directly into the output. Therefore, if we put this input again into here, it will go out in the speaker and as a loop. Then it will create a squealing sound as a feedback. So if we can create feedback, that means we have the input to output. So I'm gonna try that here. It's very easy to create. So we put them close, so you can hear this sound. And usually there is also another thing to be noted. If you hear this feedback and with the clicking sound in between, that probably means that the processing of the sound, like the input to the output, is not fast enough. So there will be some empty spot inside, let's say, in between, and then you hear the clicking. So this is how we can connect the microphone and also the speaker into the nRF through the I2 interface. So yeah, I hope that conclude this video, and I hope it helped you. Again, if there's any question, just let me know. Okay, see you next time. By the way, I'm also plan to, because now we are able to create the microphone and speaker, also interacting with them in the software. So the next step I want to do is I want to create my own audio evaluation board with the microphone and speaker connected, and let's see how it goes. Yeah, okay. That's basically for this video, so thank you for viewing. See you next time.